Let me
You were
show
saying
my
something.
Kia properly. You guys can see Kia. Hey, Kia marketing department should exploit this heavy demographic of 10 subscribers. And,
Our
yeah,
first sponsor.
yeah.
Great.
Well, sorry, you were saying something. I interrupted.
I mean, I did not have the time to do everything from scratch. So obviously, I asked Copilot to plan everything and tell me how should I start fine tuning. So
Oh,
I told that I want to I want to learn fine tuning. You suggest the scenarios and teach me uh, how you're doing it, and then do it. So that's how I started. Uh, it took a lot of time. It made a lot of mistakes, but in the end, I have some output. It's not amazing, but yeah, it is something. So it was able to do that. But on the side, while it was doing all of it, I tried to go into some of the internals which were interesting to me, and somehow it tied back to the FP32 discussion that we had. So not fully related, but yeah, I think I had fun doing all of that.
okay.
But I just spent like what 1.5 days, not enough to kind of learn everything. But it was a start.
But when you say it is from scratch, what did you mean?
Writing code myself for fine tuning, creating the data set, cleaning it, and all of that.
So the model was on your machine, or you started
Yes.
LLM from scratch?
No, not LLM from scratch. I downloaded the base
To
model.
downloaded a VM model and
Yeah.
okay.
In fact, even that Copilot suggested that okay, these are the
Okay.
base models which are suitable if you're starting, and if you because you want to do it in your machine, these are the base models probably we can consider. So that's how we went. So in the
Okay.
end, I think I used Llama 1 billion. So that is the one I
Right.
used. I tried 0.5 billion. It didn't work out that great. So finally, we landed on 1 billion.
I tried with Mistral using that
Okay.
Foundry, Azure Foundry, right? I tried to.
Okay.
So what I did was I took some Gulzar's poetry. So I separated out each couplet, and for each couplet I added I partly handwritten and partial automation. I extracted the concepts in that Nazm, and then created some 300 couplets and gave it, right. The first attempt I gave in Hindi words in English, in Roman, in alphabet, right? As in Andhi will be like ANDHIE, that kind of it. It was, I don't know, whatever it fine tuned. Okay, I mean, I give the words, it gives some random shit. Then next I did same 300 odd poems. I used a model to translate them into English, and then gave that, right, concept and poem. And yeah, I got some other thing, but I'm not able to differentiate between what it was doing actually on its own and what this fine-tuned thing was doing.
Nice. So I tried out something very basic. I was trying to find a good data set for that Shayari thing, but it flopped out. And the surprising thing is I just tried it directly on Gemini, and it was able to come up with really good Urdu sonnets, like small poetries, using, like, you just give it some context on what you want to go and build. It was able to do it by itself. So what I did was I took Phi3 model, which is a pretty old model.
5.3,
And
yeah.
yeah, then I went ahead and took a data set of basically simple math problems. It is like things like, you have those puzzles that are asked in quizzes during interviews or for kids, right? SATs, that you are 30 years old, your sister is X years old. What is the how many years old will she be after 10 years? So things like that. And the difference and the data set that I used was from Hugging Face, which basically was in this domain only. And the difference is like very clear. It's the original 5.3 model versus this, right? One goes into a really big set of explanations. The other one basically is very concise and very terse to the point. So that data set definitely helped. Uh, and yeah, I didn't go and write code and all. I used Unsloth to go and do that training. Uh, I was trying something else with text to speech, but that didn't work. Wanted to get a model which actually speaks in a particular voice, um, but that didn't work at all.
Shall we go in the order? You want to show your?
Yeah. You want me to show?
Yeah, you can start.
Okay.
Yes, please.
Let me start again. So what I tried is two different scenarios. First one was limericks, training the model to output limericks, and second one was pirate speech, that the model will always output in pirate language. So that is what I tried. And so see, this is the output for the first one. And this is the one I think we spent most of my time with. You can see, so you give a topic and there'll be a limerick in top.
Cat that
It
loves
is
to code. Okay.
Yeah, like both of them. So limericks have a very specific rule, right? 5 lines.
Right.
And the pattern is A, B, B, A. So first, second, and fifth line should rhyme, and third and fourth should rhyme. So that is it. I think there is some rule around syllables also that these lines should have like A, first, second, and fifth line should have more number of syllables compared to line 3 and 4. So those kind of rules are there for limericks. So mostly, I think it is able to do it if you see the output. So in this, cat that loves to code is a feline in his abode. He's an app developer cat and he writes apps. That it cheated here, so it started the next line, which is rhyming with that word, and then means he can build and deploy his abode. The limerick itself doesn't make sense, but at least it is trying to follow the rules of limericks. So that is what it is trying to do. So initially I started with haikus, but it didn't work out that great. Then I finally moved to limericks. And I started with like this 500 million parameters model, the Quen 500 million.
Right.
And the issue that we found out was that that model does not understand rhyming that much.
Correct. Same.
It doesn't know the meaning of rhyme because first of all, it has less training data compared to it has less weights and training data compared to other models. And I mean, it is difficult, right? In English, rhyme is not directly related to your spelling. You might have the same similar spelling at the end, suffix, but it might not rhyme. And you might have very different spelling, but it would rhyme. So what you really need is understanding of phonetics. That at least this model did not have. So no matter what we showed, it just could not rhyme. It was able to kind of use the other rule that, okay, 5 sentences and all that stuff, but rhyming is something that it could not learn, no matter how much we tried. Then
it captured the syllables, is it? Syllable is also another concept complicated for usually, right?
So number of syllables it did, but nothing apart from that. Lines and number of syllables. That's it. Nothing
okay, even number of syllables is not trivial, right? Because it is not tied to number of characters. Or
it was not. Yeah, it was not super accurate, though. But yeah, it did a decent job. Then I think Copilot gave a good suggestion that why don't we do this thing? Why don't we pick some models and I will scan them to see which of the models understand rhyming untrained. And then probably one of those models is our candidate model that understand rhymes by default. So I think we tried 3 or 2, I think. Quen 2.5 to 3 billion, Llama 1 billion. And there was third, which I'm forgetting right now. So both Quen and Llama were good at rhyming. So it just asked random questions and it asked them to rhyme and it was able to give the output. So we finally chose Llama 1 billion model. And that's what we trained. Even there, we had issues initially. The model was mostly cheating. So that's what we found. So it was able to rhyme. So I had a check-in script, okay, that needs to understand the output, that if the output is actually a limerick or not. So, and the rules were, okay, the same thing. The first, second, and fifth line should rhyme, second and third should rhyme. But what the model did is it used the same word for all 5 initially. And then it used the same word for first, second, and fifth, and then third and fourth. So obviously my checker was not checking that initially. So then we pivoted to also checking the diversity of rhymes, like the words that are rhyming and all of that. So it improved a little. Then what we figured out is why don't we plan the rhyme words beforehand only, and then ask the model to create the limerick. So if you see here, so we changed the training data based on that. So we modified the training data to have plan plan also, which is this. If you see, plan A is aboard, and B is cat and that. So the A lines, the first, second, and fifth lines will have this. So it is planning this beforehand, and then it is writing the limerick. So then the performance improved. So that was the final state that we landed.
Nice. Yeah. Can you show your test data?
Test data. Okay. It is in Python. It's in Python.
Oh, okay.
Yeah.
PyRO,
Give me some time. Maybe you guys can show it, and I'll try to maybe display it in a slightly nicer format. You want to go next?
Okay. Let me share my screen. Yeah. So I have these. You can see my text.
Yep.
Yeah. So what I have was this text taken from some lyric sites, right? And I split them into two lines, and for each one I added my own concepts, right? Then I had 300 odd such couplets, right? Then I have this guy. Oh, okay. I used a Copilot to create this Python script, which takes that whatever the poetry text into JSON-L, which is accepted by our models. So I deployed one. I used Foundry here. Basically here, just fine tune and you choose the base model. So the first one was like this guy, where I the JSON file was the JSON-L was whatever I showed you just now. Okay, let me show the JSON-L as well. So yeah, so this is like JSON, multiple JSON, one JSON per line, right? The JSON-L format. So there is the system prompt, and that you are a poet who writes in Gulzar style in whatever thing, and the actual content is the Gulzar's actual poem. This is again this is in that Hindi one, Hindi/Urdu in that Roman script. And here I gave the content, like dream, ice, magic, whatever, right? What I expected was, this was the one fine tuning one. I'll just show you what shall we run it or?
Yeah.
I need to give this guy. I don't know. On road. Autumn. What? Give something light. Good. See, random shaded. Turn road. I mean, first of all, it is repeating whatever this is. Gulzar ke saath aapka shayad dil mein aapka whatever, right? It is some random shit it came up with. Now, so then I gave up on this. Now what I did was that I used a model to extra. I mean, basically, whatever this one is there, I extracted English translations of it. Let me show you the Gulzar translated.txt. So it is similar in concept, but right. So I have again love, life, strength, weakness. These are the concepts, and this is some model's translation of this guy, right? Some Gulzar's poem, it got translated into this. I have no strong opinion about how good the translation was. I just wanted to get the end-to-end running. So later we can probably use a better model, but it was okay translation. So it said as the heart has made all things its own, whatever, right? Now this I gave to the next model. This guy. Now, where is this? Now, so its prompt is. Sorry, you said something. Now, again, what I forgot the name. Autumn road turn light. This is slightly better, right? A whispers of autumn's breath, a road turns, light's gentle kiss. This time I asked it to generate. Now the question is, would it have generated exactly the same? I mean, if did my fine tuning help at all? I have no clue, right? I'm not sure with that part. Like if I gave exactly the same prompt on a base model, would it have given exactly the same thing? That I'm not sure. Yeah, the fact that it struggled with the older version, that seemed to make sense to me. Like because in its training model, in its training data, it may not have any of those concepts about shayad, all those Hindi words, right? So it kind of sort of made sense to me, but vague sense. But yeah, I mean, for this I do not know. I mean, I am not connoisseur enough to know whether this poetry is in style of Gulzar, but the default one is not in style of Gulzar. That much and all that I did not know.
It is very difficult to make that judgment. This is first of all in English.
Right,
Yeah.
right.
Yeah.
But yeah, I mean, there are. I mean, what I learned, a side effect was that when I was trying to extract the concepts from Gulzar's poetry, I realized that he's obsessed about these modes, and I mean, his analogy for relationship is something like a mode, right? Is modes se jate hai, that kind of thing. Like, so those turn and road and all, they keep coming across. They keep coming up too often. So I was hoping that something of that sort can be captured in the poetry, but no, I didn't reach that point. But this is super fun. Like Foundry is super easy to fine tune. Perhaps a few more records, and maybe things could be better. Their instructions is talking about something like 1,000, 1,400, 1,500 kinds of records to fine tune, but I stopped at 300. You want to go, Alan?
Yes, sir. Yeah, I can go. Okay. So, like I said, what I was trying was something very basic. So this is Unsloth. I'm using Unsloth as the UI. So
Yeah, you can
basically,
tell a little bit about Unsloth for
yeah.
our viewers.
So this is a locally run UI. Everything is running locally, and you can go and download your models, right? So on this device, for example, you can see that I've got Gemma 4, 5-4 reasoning, right? So these were lying around for some time in LM Studio, the 5-4 one. So it's pretty easy to go search for these models if you want to take a look at GLM Right now it's not there. This is on device, sorry. Yeah. So GLM, you can go download it, start using it. Okay. Now the fun
You
part
actually
is,
trained it on your Mac machine.
yes. So out here is, these are the ones that I have right now. So, and this is, as you can see on device, these are the models that are present. And if you want to go and start training, there's a training option out here. You select your model. Then if at all you want to select a Hugging Face model or not, basically local model is being used, so you don't need Hugging Face. And then the type of method, right? So this is one
Oh,
thing that I was trying to understand a bit better. Basically, I was again using Gemini to understand a little bit of what exactly is going on, right? I was thinking that because of the data set, it was more fine tuning based on few shots, but that's not the case. So this is the inherent difference between going and trying to get something via few shots versus using something like a LoRa of PFT model, right? So what is going on here is that it is just generating a new set of weights, which is then added onto the exact same model. So the whole model isn't being changed. That's why you can do it locally. And the ability to go and have just the delta trained is what allows you to do it on your local Mac. So it just uses a few gigabytes of RAM and it's able to create a new model out of it. So along that same lines, right? If you take a deeper look into what exactly LoRa is doing, this is what I just said, right? And people have got multiple variations of this. Say you have a baseline model and you want to fine tune it like for the Shirey or for anything else. That delta is what is actually available either online or they go ahead and merge the entire model and then you can use it. So if you take a look out here, once this is generated, so this is the model that I generated. I can export it to GGUF format and this I can host it on Hugging Face or share it with you guys. And it's exactly the same size. So the size of the model does not change. They say that the difference might be like way less than 1% or 0.1% kind of a change. Okay. So
why would
you,
there even be a change? Sorry, I didn't.
yeah, there shouldn't be, but that's what they say. Worst case scenario,
There
that's what.
would be no, because
Huh?
you're adding a new small matrix, two small matrices as part of LoRa.
Is
No,
That
it?
should
No,
make
right?
some.
They are
no,
modifying.
that's
I
not.
mean, the picture is saying that we are modifying the
Yeah.
numbers.
So if you take a look out here, right, the dimensions of the matrix are such that you're just multiplying the delta with the existing matrix. So it's only going to change, the size of the matrix will remain the same. So it's going to change some weights in the matrix, but it's not going to increase the size of the matrix.
Okay.
But this is one area that I'm a little confused because I was reading that book that build your own LLM, the Sebastian Rasha's book, right? LLM from scratch kind of thing. By scratch he meant by starting from PyTorch, but there he implied something like I think his example was something like you have a foundation model and then you fine tune it to give that say sentiment, right? So some supervised text. There he my memory might be corrected, but I think he is implying something like last layer he will remove it and put another layer, which last layer was normally predicting a new character, right? Normal foundation model. In his fine-tuned example, I think he removes the last layer and puts a one, which will give that that. What the either true or false, right? Positive or negative kind of thing. So
Yeah.
they remove the last layer, put another layer, and that one is trained based on the supervision text. But this
Right.
seems like we can. It is not just limited to only the last layer. This entire thing can anywhere it could change, right? Whatever
Yeah.
are the low thing.
Yeah.
Yeah.
Like visually, you see this, it actually kind of showcases as if it's just one layer, but these details I
Yeah.
have not gone into, right?
Got it.
So I need to take a look at this. But that's what these differences in the way that you fine tune, right? You can of course go and fine tune your complete model, and that's when you need all of those GPUs and shitloads of memory and all of that. to this Unsloth, the data set that I used was, this is a very small data set. So if you see in fine tuning, you can go and specify user and assistant and system tags, right? And within the tags also, you can go within the text, you can go and specify sentiment and things like that. So these are some small examples. This is an Orca data set from Microsoft itself, available on Hugging Face. So I went and took a look at this. So if you go and try any of these, right? Let's see.
What 200K problems are there? Is it? What
Yeah.
does that outcome? Oh.
Yes. This is 200K.
Oh, that is small data set, is it?
As in out here, if you take a look, it's not small. Yeah, forget that. That's a wrong statement to make.
Okay.
But it's pretty simple to take a look at your data sets, which ones are actually available, and then play around with them. So out here, plus it provides me the ability to go and check how exactly these were. Let's say this is the one, right? So there's a compare option out here. And what I gave is this dumb problem, right? That this is the age difference between me and my sister. What is the
You are
age after
30.
something?
What is that? Base
Yeah.
16 or something?
AI wise,
Yeah,
I am 10,
yeah.
not
Okay.
30.
What
So
will my sister's age be 10 years from now? Okay.
yeah, so it's a
Okay.
pretty dumb problem,
This
right?
is
But
this
if
is the output. The output is the default output, or you are
this is the base
fine
model,
tuned
you can
base
see
model.
here, this is
Okay.
the base model, right?
Oh, okay.
So you can see that it has gone and tried to overthink on it. And on this side, this is the fine-tuned model. And you should be able to see that it's much more concise, right? And that's true for any problem. If you try to go, there is one dumb problem which does not really have a solution. It went into, crazy explanation on it. This guy, on the other hand, was able to go into the details and come up, with the answer saying that, hey, this is something seems to be wrong out here. Okay. So the difference is pretty stark in the amount of, you can say, thought put in, or actually, if you just take a look, tokens itself, right? Here it has, for this problem, it has consumed 35 tokens. Here it has just 22 tokens. So
yeah, that
there's
is the
that.
main advantage of that. Right?
Yeah. So that's about it. Yeah, I use this for local training, and
Can you show me some of the test data here, please?
yeah. So where is it gone? Should be able to load it on Hugging Face itself.
So the inference was also happening on your machine, right?
Yes.
When you are showing.
Yes, everything is local.
So it works fine, Alan. You have to shut down all other apps.
No,
and
it's working fine. I've got everything running right now. So
all.
if you
It
take a
only
look,
take a couple of GPs, not more than, depending on your
Is
base
it?
model. Yeah.
Okay.
so yours is
So
the,
okay, we'll come to that.
yeah, this is the data set that is there.
What is Acha question? And here they gave explanations, is it?
Yeah.
Okay.
So the essential thing is how to actually come up with that answer, right? Rather than going into a complete loop. So this is much more to the point, and it seems to give the explanation much better than the default model.
Hmm.
So yeah, and
Well,
plus
so
this, yeah, sorry, go ahead.
no. I think this seems like a like a carefully written data, right?
Yeah. So this is from some other data set, it looks like, but Microsoft generated, so I'm sure that it's used someplace.
Right.
And you use all of it for fine tuning or some subset of this data set?
It's used all of it. I don't think I provide. Actually, that's a good question. I don't think I provided any. Yeah, I had none. So I don't think there is. No, I'll have to check that whether it has used the entire thing. But I didn't provide any option. I used the defaults that were there in Onslaught. Yeah, that's about it.
Yeah, I think, I mean, that the 200K seems to be the huge difference, right? You're clearly seeing the difference between old and this, right? Which
Yeah.
I'm not able to see at this point.
Yeah.
Maybe I should try that part.
Like, if we wanted to fine tune, right? Why would I take a bigger model?
Yeah, that is a point.
Yeah, it's
Because
already.
even the base.
Yeah.
Yeah.
No, you would want to, right? As in you, so if see in my training data, I have the concept, the set, the superset of the concepts is limited. Suppose I want to go outside that, right? What if, say, Gulzar never wrote any poem about bicycle or I don't know, motorcycle or whatever, and I want to write that.
Yeah.
That you would want the bigger model to know, right? I don't know. I'm
No, but
off.
bigger model would also do it by itself, right? Those are the patterns that it has already learned. If you ask Copilot, sorry, if you ask ChatGPT, it will give some sort of coherent output in the scenario. So the bigger the model gets, even without fine tuning, it would be able to do these kind of jobs. I think the advantage we are getting is, as Alan also mentioned, number of tokens might be like it might be faster.
Finer,
It might
yes.
Be, yeah.
And but I mean, that is one, the number of, but I think we'll be more aligned to the tone of the poet that we are aiming for, right? It is very unlikely that, say, I think even now, good models will struggle to get that proper ghazal, right? Even the state of the art, because they won't be able to capture the rhyming as well as the rules and all those things. I really doubt that. Maybe I can try it out and share that part later. But I get your point that, sorry.
No, I was saying the smaller the model you take, I think the difference would be more starker in the outputs after fine tuning. That ideally should be the case. If you have done your fine tuning well, if your data set is good.
Yeah, the bigger the model, I feel that context, what you're saying, I kind of agree, but that is, see, what are we trying to fine tune, right? Let's take, in this case, the poetry. Okay. Now I've got a smaller model. If I'm able to get a good data set, I should be able to at least replicate similar poetry, right? But what you're saying is when you go out of context in terms of saying that, hey, such kind of poetry is not written before. Now write poetry with, say, love and death, like whatever I provided, right? Now, the fine-tuned model should be able to give some basic context in terms of English to whatever we have fine-tuned, right? So why would I need the bigger model? Like,
I can give one example, right? As in, imagine the model is, say, I give a word that is not in a different language, right? So would a smaller model be able to capture that? Unlikely, right? I don't know, Telugu word or something like that. Huh?
Yeah. I think that's okay if it's language specific. Like, imagine that the model does not understand Urdu, then leave it aside, or does not understand Telugu, leave it aside. But if it's able to do basic translation, right, from one language to another, then it should be able to get that context from its corpus that's already there, right? From its memory that's already there.
Right. That memory is you will get only from a bigger models, right? No.
No, I know you'll get better from a bigger model, but
I
why?
get your point. I mean, I see that if I have to put it in my words, what we are saying is bigger model can automatically do whatever you are attempting using fine
Yeah.
tuning. Bigger model can
Yeah.
automatically do it, right?
Yeah.
Say most probably Opus 5 or whatever will be able to directly give the ghazal in the format
Yeah.
you want.
Yeah.
Hmm.
And it's also cost wise, right? That when I'm trying to fine tune something, I want to find the best model, and ideally the smaller one will be cheaper for me. So if I'm just taking, say, imagine I had GPT-5 access, right? And I fine tuned that GPT-5. Now, great, I fine tuned it, but running it is going to cost me the same thing on my infra
Correct.
also.
Correct. You
So
are only saving the prompt or
it is,
not having to give the whole token,
yeah,
whole
the
context and
context
all.
window, exactly. That's what I save on. But
Correct.
otherwise, is it really beneficial?
Right. Yeah. But I think the exact nature of the small and big is something that we need to understand, right? What do we mean by small? I mean,
Yeah.
these are like 3 billion, 3.5 billion, or no, 375 billion or trillions, right? And we are talking about 3, right? Probably there is a difference in, say, 3 and 7.
Yeah.
That is
But
something that.
see, even 5.4 and all, the models actually, if you take a look, right, some of the documentation talks about how 5.3, 5.4 were built. So they actually went ahead and took the GPT models, as in the frontier models, to go and clean up their data sets, right? And with that, they actually built smaller models. Earlier, it was smaller models were meaning that you're taking less time for training and all of it. But there has been a lot of investment gone in building better, smaller models, right? And that's what you're seeing even with this Spark and Gemma 4 and all of these, right? Which are now Google is shipping it as a part of Chrome. So you have basic models coming on the machine itself. And that will give you the ability to go and have things like, write me a text to send to Sai that I won't be able to meet him today, right? Patak, it will actually integrate and do that. So those kind of scenarios, I think, which is going to be the most
Understood.
common case. Yeah. But yeah, I think this was good. I at least spent some time looking into something.
But what is the conclusion? Can we? Do you see any use of it in our
Yeah,
in
the data sets are super important,
Yeah.
right?
right.
I wanted to try something like a RFP generator, okay, but there's no RFP data set. But
Right.
now in a company, like imagine that we were running a company and we had our RFPs. It makes a lot more sense for us to go and actually do that ourselves. Because why keep on paying for the additional, like you see today what they do, right? They pass in all the RFPs and say that generate a new RFP like this to co-work. That's what people are doing. But if you had a customized model, you have that context which you can keep refreshing weekly or monthly or whatever. And then the RFP generation is pretty quick, token count is low, all of those benefits you get. But
But
yeah,
at least for this, you would need still a pretty big model,
yeah,
given the
maybe.
size of the documents and the context window that you would need and all of that.
Yeah, that's the thing. Maybe we can, I don't know, we'll have to try it out. Say with the 5.4 model, at the end of the day, it does decent with English text anyways. The question is, if we train it on generating RFPs, will it do a good job? We have to try it between, say, a 5.4, a lower model that is fine-tuned versus a bigger model that is not fine-tuned, maybe, right? Because the bigger models anyway, you cannot fine-tune easily, right? But that is one thing that is useful, but there's no data with us. It's companies will have the data.
But I mean, wouldn't we be able to fine tune per customer?
Yeah. But then the
Hosting
customer,
is a problem.
Why
Would
that?
you
Right now, like Foundry.
you will host it for them, or they'll host it
Yeah,
themselves?
We'll host
My
it for
question
them.
would be, why would we do it? We would just tell them to do it, right?
No, it is non-trivial, right? As in even what I did seemed like I had so many questions. Why would anyone want to know about all those things? What do we want to extract and all, right? There is going to be some sort of tribal knowledge involved in building this, how to validate it, and how do we making
Yeah.
sure the data is clean and all.
I think
It won't be
that will
trivial,
go down.
right? Huh?
Right now that might be the case, but it might go down the need of that tribal knowledge as the tools evolve and become more sophisticated. Even right now, Foundry is giving you very minimal options, right? Look at Unsloth, for example. It lets you do so much. Like Foundry is extracting out most of the things from you. Maybe there'll be tools that are even higher level, like one click and you're done. Just provide the data set and you're done.
And unless you see the data, it becomes very difficult, right? Like if I had not seen the data set, then I don't even know what to expect, whether the output is better or worse or what is it. Now with customers, how will we as model hostess take a look at that data?
Yeah, we don't have to. AI, I mean, first validating the model, we will use a normal high-end model to validate the data, and then deploy it.
Okay.
But I'm forcefully introducing some application here. I'm not seeing any major benefit.
Cool.
Just that they will have complete control over that, right? If they want, they can put it on their own. They don't have to worry about, hey, my data is going to OpenAI or Azure or whatever. We can fine tune them and give it to them, and they will. Yeah. Anyway, we are coming to an end of our hour.
Yep.